Okay. And this looks like spider legs. What's that called? Yeah. Arachnoid motor. Right underneath her, guess what's being also produced? Cerebral spinal fluid. So you have three places producing the cerebral spinal fluid. What's the general flow?
1, 2, 3, 4.
Lateral, that goes into the third ventricle. How does it get through the
Interventricular foramen.
Interventricular foramen. Perfect, yes.
What did you say about three places?
Three places that make it. Choroid plexus, epithelial cells that are lining everything, and then right underneath the arachnoid motor also.
So what would that be called? Arachnoid space? Arachnoid villi?
No, the arachnoid villi is sucking it up.
But is the arachnoid matter actually making the cerebral spinal fluid?
There's epithelial cells that are lining it as well.
Oh, okay.
Okay, so, well, but one's happening inside the brain, the other one's happening outside the brain. Okay? How much cerebral spinal fluid do you produce a day?
A lot.
A lot. 500 milliliters. How much do you have in your brain at once usually? 120? 100? That's not much, is it? It's constantly being cycled through. Constantly being cycled through. Where does it made from mostly?
Where is it made from?
Yeah.
Epidemius.
Mostly water, and there's, she said a great answer. It's similar to blood plasma, but it's a little different than blood plasma. One thing, there is absolutely no proteins in it. There's no protein in it. Okay, that would be bad. Another thing is, you don't want other chemicals that are in there, like toxins from bacteria, or bacterial pieces, or viruses getting in through there. So, everything has to go through the epithelial cells to get into making the cerebral spinal fluid. That is the big filter kind of thing. All right? And it's also going to have a higher salt content. Why does it have a higher salt? And by salt, I mean sodium. That's a good answer, yes. Sodium. Why does it have a higher sodium content?
Because of how much neuro messages are going to be.
The actual potentials have salt channels, sodium channels.
These are all good ideas. I like these ideas. But what else does sodium have?
A lot of bacteria can't live in high salinity environments.
Well, that's interesting.
The sodium is the one that
Anyone ever go to the Dead Sea?
No.
Like
Ever
the
see
song?
The Dead Sea?
We don't have time. We're in school. Sorry.
I've never been to the Dead Sea,
Oh
but
yeah,
I love the Dead
buoyancy
Sea.
for your brain. That's what you're trying to get at.
Buoyancy for your brain. It increases, the higher sodium levels increase the density of the water. Okay? So, you increase the density, what's going to float in it? The brain. What's the brain mostly made out of again?
Fat.
Fat. What does fat do in water?
It floats.
It floats.
That's why
All
they
right?
float.
So it tries to make sure that the level of your brain is pretty good. So it's basically what's the buoyancy? Like when you anybody has a diver here? A diver? What's the type of buoyancy where you want to be? You don't want to be positively buoyant, you don't want to be negatively buoyant, you want to be what? Equilibrium. That's sort of what you want your brain to be. It floats a little bit, but mostly it's just the same density, so it just stays in this nice fluid pack. All right?
Can we go over since we kind of can we run through the properties of the cerebral spinal fluid one more time?
Okay. What are the properties?
It's cushion.
Salinity.
High salinity, no protein. Next one. No toxins. And actually it also has lower levels of potassium and chlorine in it as well. Isn't that weird? It has lower levels. Because they don't want too much in the brain or it becomes problematic.
So, like, what happens when someone drinks? Like when someone drinks, like in the chlorine.
You said
The
chlorine?
is there already, but it's in lower levels. Yep. Yes.
So,
Compared to the blood.
the no protein, is that to stop stuff from randomly binding to your brain and creating plaques and doing
These
bad
things are all
things?
very good ideas, yes.
Yeah.
Because proteins also have, a lot of them are enzymes.
Yeah,
And
they
you don't
do.
want enzymes doing what enzymes do. You
Catalysts.
want very controlled environment.
Is it possible for proteins to get into it?
Yes, that's a bad thing.
Something.
Yes, that's a very bad thing. Because usually that means a problem with your blood-brain barrier and everything like that. And
Is that why they do spinal taps?
spinal taps, they're usually looking for levels being off, or they're looking for bacteria or viruses in there. And bacteria or viruses are going to cause pressure, and pressure on nerves is not good. Okay.
Body's so
So,
cool.
we got the fluid, we went through the interventional deferment. We're in the third ventricle. What do we do now?
Go cerebral aqueduct.
Cerebral aqueduct.